These are the notes for section 4.7, Inverse Trigonometric Functions, day 2. As a review, inverse functions are functions that undo each other. For example, addition and subtraction are inverse functions. If we start with x and add 5, we would get x plus 5. To undo that, we would subtract 5. X plus 5 minus 5 would get us back to x, so therefore we did and undid an operation. Similarly, multiplication and division are inverse functions. Squaring and taking the square root of a number are inverse functions. Similarly, taking the sine and the inverse sine are also inverse functions, and that obviously works for the other trig functions as well. When you evaluate the expression inverse sine of x, the input x is a ratio, and the result is an angle measure theta. That is, the inverse sine of the ratio x is equal to the angle theta. The inverse sine function means theta is the angle for which sine of theta equals x. So, for our first example, we're going to use a right triangle to write this expression as an algebraic expression. So, this is kind of a hint that we have to use a right triangle. However, if you just saw this expression, you would need to know that you need to use a right triangle. So the way that I think about this is I know that the inverse sine of some ratio is equal to an angle. So then what I have is that the inverse sine of negative 3 over 7 is equal to theta. So I can rewrite that, and I can say that the sine of theta is equal to negative 3 over 7. So you can actually drop this back kind of to SOHCAHTOA. For SOHCAHTOA, right, our sine is our opposite over our hypotenuse. So for me personally, I put this on the coordinate grid. So I'm going to put this on my coordinate grid. And I need to remember that the inverse sine only lives in quadrant 1 and quadrant 4, right? So I don't want to build my triangle in quadrant 2 or quadrant 3. And I want to think out of quadrant 1 and out of quadrant 4, which one has the sign negative? So after thinking about that for a second, hopefully you realize that means that our angle theta should be in the fourth quadrant. And now our sine is our opposite, so 3 over our hypotenuse, 7. And I need to think about signs here. I need the overall sign to be negative, the hypotenuse is always positive, and it makes sense I'm moving down, so that should be a negative 3. So now I want to find the cosine of that, right? So I want to find the cosine of sine of negative 3 over 7 is going to be equal to cosine is the adjacent over the hypotenuse. So we need to find the adjacent. So I'm going to call this x because it's moving in the x direction. So x squared plus negative 3 squared is going to equal 7 squared. This is 49, this is 9, so x squared is going to equal 40. So then taking the square root of both sides, this is a number, so I'm remembering plus or minus. So I get x equals plus or minus 2 square roots of 10. So the next thing that I want to think is, should this be the positive x value or the negative x value? So since we're moving right, our x is going to be positive 2 square roots of 10. So then our cosine is our adjacent, which is now the 2 square roots of 10, over the hypotenuse, which is 7. So my answer to this problem right here is 2 square roots of 10 over 7.